Some new excitement for monitoring Earth from space is launching up as early as this afternoon here from India. Joining me now to talk about the new NASA NISAR is Dr. Karen St. Germain, NASA's Director of Earth Science. Karen, thank you so much for joining me today.
It's great to be with you.
So first, let me ask you this. How is NISAR going to vary from other Earth-observing satellites and instruments that we have in space?
It's a great question. NISAR will be the most sophisticated radar NASA has ever launched, and it will see the Earth at a level of detail and precision that we've never had before, down to changes at the centimeter scale over areas as small as half a tennis court.
And one of the special things about this is that it's not, a satellite where we're taking pictures of the clouds. It's got radar instruments on board that allow us to see the Earth in a different way. Can you talk to us more about that?
Yeah, exactly. Unlike a camera, a radar transmits a pulse of energy, and that energy goes all the way to the surface of the Earth and bounces back. So it can see through clouds and even vegetation, tree, foliage, and so forth. And it can see these small changes on the Earth's surface that happen because of land sometimes sinks a little bit when the aquifers underneath are depleted of water. So we can actually watch land go up and down as those aquifers get depleted and recharged. We'll be able to see glaciers moving and snow, which is an important source of water storage in the mountains. And we'll be able to see changes to coastlines that can affect not only coastal navigation, but also the infrastructure in those coastal communities.
And this is possible because there's not just one radar, but two radars on board, right?
That's right. That's right. NASA built one radar and the big antenna. Our colleagues in India built the other radar and the satellite bus that the instrument sits on. So these two radars are sensitive to different types of structure, and that means we'll get a really complete view of the surface of the Earth and the structures on it and how they're changing.
And how frequently are we going to get new images of any one given point on Earth?
Yeah, it'll be about once every 12 days. And that's because we're doing this at such a high level of fidelity. But the satellite will come around overhead any given spot once every 12 days. And that's how we'll be able to see change that's happening over time.
And you mentioned some of those changes are very on a small scale. We're not talking feet. We're talking on the order of, what is it, millimeters or centimeters?
Yeah, about half an inch or better is the kind of change we'll be able to see, which means things like, sometimes before a volcano, there'll be a little bit of a bulge before that volcano erupts. We'll be able to see that as just one example.
Can you talk to me more about the applications with maybe farming or tracking drought or changes to other ecosystems, like we have the Okefenokee Swamp in South Georgia, which is a big source of carbon sinks. How will this new NISAR in space be able to track changes to those?
Yeah, so one of the great things that this radar is going to be able to do is measure soil moisture. And that's really important for a wide variety of reasons. One of those really important ones is, of course, farming and water management associated with agriculture, farming, and ranching. But another really important use of that data is to assess when things are on the dry side. Fire risk, and when they're on the very soggy side, that increases flood risk. So there's a wide variety of ways that we'll use even just the soil moisture data that we'll get out of NISAR.
And what about big picture, Dr. St. Germain, with, we've got these natural disasters that happen, from hurricanes to wildfires to floods. How could NISAR potentially help those emergency responders seeing changes during and maybe after a weather disaster?
Yeah, this is one of the most important and impactful applications of this data. Because NISAR can see through clouds, it'll be an incredibly important tool particularly after or during or after an emergency where emergency responders are trying to get situational awareness of what's happened, where there is damage, where people might need help. But another really important way that we'll use the data is improving our ability to predict when these kinds of events will happen. So that means improving warning times and warning areas so that people are less vulnerable to these kinds of events in the first place.
And how long do you think that NISAR is going to be operational, giving us those images every 12 days?
Well, we've designed NISAR to last for at least 3 years. That's what we call prime mission life. But many times our missions last much longer than their prime mission life. So we have hopes for a long life for NISAR on orbit.
And tell me about the launch time to time being operational. What does that journey look like after it launches?
Well, this is such a sophisticated instrument that it's going to take us some time to get it fully deployed and activated. For example, it'll take days, about 8 days, for just the antenna to get fully deployed. And then we'll have to activate the instruments, go through the calibration and so forth. So upfront, it'll take us a couple of months to get the data really flowing and ready for the science and the applications. But once it's rolling, NISAR is going to produce more data than any mission we've ever had, and it will all be openly available for both scientific use and applications around the world.
And I know that scientists in NASA and in the weather world are very excited about this, but why should the general public be excited about NISAR?
Well, NISAR is going to have applications in every single community around the country. Whether you are in a region that is prone to floods or wildfires, earthquakes or volcanoes, whether you're in an agriculture community that relies on being able to produce, every community is going to see the benefit from this instrument and the science it enables. And frankly, that's what really excites me. The science is awesome, but putting it into use, putting it into the hands of people who can use it is really what gets me fired up.
Dr. Karen St. Germain, NASA's Director of Earth Science, thank you so much for joining us today.
Thank you.